students, welcome to Visionary Heights. Today in the trigonometric series for grade 10th, we're going to start our part 3rd. If you're new to the channel or haven't seen the earlier part, I would recommend you to check them first. In the last part, we learned about two things. One was the reciprocal identity and another one was the quotient identity. What is reciprocal identity? Reciprocal identity says that all the trigonometric ratios, suppose I have sine theta. What is the reciprocal of sine theta? All of them have their reciprocals, right? One ratio can be changed into its reciprocal. What is the reciprocal of sine theta? That is cosec theta. So sine theta can be written as 1 by cosec theta. Similarly, we can write cos theta as 1 by sec theta. Okay, or the reciprocal of cos theta is sec theta. And what is the reciprocal of tan theta? That was cot theta, or tan theta can be written as 1 by cot theta. They are just the reciprocals. Means if I want to convert sine to cosec, what I have to do? I have to write it 1 by that number. Means they are just the reciprocal. Or we can convert sine to cosec, cos to sec. Similarly, tan can be easily converted into the cot theta. That was my reciprocal identity. Now, what was our quotient identity? Quotient identity says that if I have tan theta, if I am writing tan theta can be written as good sine theta by cos theta. It means I can convert this tan theta, or I can write tan theta in terms of sine theta and cos theta. Means the conversion of tan theta is easily into sine theta and cos theta if we know the quotient identity. What was the next one? It was cot theta. So cot theta can be written as, it can be written as cos theta by sine theta. Okay, means we have written the relation between the tan theta, sine theta and cos theta, and cot theta, cos theta, sine theta. Okay, tan theta can also be converted into cot theta because it is just opposite of it. Cos we can convert into sec, and sine we can convert into cosec. Hope till this point it was clear to you. Now we have to learn one more identity that is known as the unit identity, or we can call it the relation between the tan and the sec. Okay, so what is that? Very, very important, that sec square theta can be written as 1 plus tan square theta. Alright, and cosec square theta can be written as 1 plus cot square theta. Now with this, we have developed the relation between tan and sec as well. Tan and cot, I know the relation. That is reciprocal. Tan and sine and cos, I know the relation. But now we have developed the relation between sec and tan as well, right? And here between the cosec and cot as well. Hope it is clear. When we will be solving the question, it will be clear to you why we are learning these identity. Basically, the part 3rd is based on the identity. We have to make use of all these identities and we have to solve the question. This part is really, really important because most of the question in your exam will be from the identity portion only. So don't you afraid of it. You know the reciprocals. Reciprocals are sine is the reciprocal of cosec, cos is the reciprocal of sec, and tan is the reciprocal of cot. In the quotient identity, we have two things, that tan theta is sine by cos, right? Similarly, cot is cos by sine, just the opposite of it. And then these two identities, that is sec square theta is 1 plus tan square theta and cosec is 1 plus cot square theta. We know the relation between the sec and the tan, cosec and the cot, but what about sine and cos? Yes, very, very important, that should not be forgotten, and that is, if I have sine square theta and cos square theta, that will be equal to 1. Okay, if I have the same angle, see, the angle is same here, it is not different angle. If angle is same and I add the square of sine with the cos, it will make me it will give me 1, right? So sine square theta plus cos square theta is 1. Very, very important. Now using all these identities, we are gonna do some of the question. What is the use of all these identities? Why we are learning these identities? Basically, these identities they develop a relation between different trigonometric ratios, right? As we already learned the reciprocal one, tan is making relation with cot, sine with cosec, cos with sec, right? Similarly, in the other identities as well, we did the same, right? Like sine square theta cos square theta is equals to 1, means there is a relation between sine and cos, because sine square theta plus cos square theta is equals to 1. If I want to make the relation, so sine square theta can be written as, if I shift it to right hand side, become negative, so 1 minus cos square theta, right? Means this make a relation between sine and cos. Similarly, for tan and sine and cos, what is the relation? Tan theta can be written as sine theta by cos theta. Is it clear? So these identities are if we wish to convert from one trigonometric ratio to another. Now, suppose my question is that you have to convert tan theta to cosec theta, right? I wish to convert this. Now, how to move from tan to cosec? Basically, in order to move from tan to cosec, I don't have a direct relation between tan and cosec. But I know one thing. Tan can be converted to cot theta. How? How I can convert tan to cot theta? By reciprocal identity, right? And cot can be converted into cosec theta. How cot can be converted into cosec theta? We just learned. Very good. 1 plus cot square theta is equals to cosec square theta. So basically, if I wish to convert tan theta to cosec theta, first I should convert this tan theta to cot theta and then to cosec theta. Let's learn how. So tan theta can be written as 1 by cot theta. Is it okay? And I know one more thing, that 1 plus cot square theta equals to cosec square theta. Is it okay? So in place of this, I can write cot theta can be written as 1 by tan theta, right? So in the identity, I can write it as 1 plus 1 by tan square theta equals to cosec square theta. So 1 by tan square theta is good cosec square theta minus 1. So if 1 by tan square theta is equals to cosec square theta minus 1, so tan square theta will be how much? If I am doing the reciprocal of the left hand side, I have to do the reciprocal of right hand side as well. Or I can say I am shifting this tan square theta to right hand side. So this will come to the base. It will become 1 by cosec square theta minus 1. So what will be tan theta? Taking the under root on both sides. Root of 1 by cosec square theta minus 1. So this is how we have converted our tan theta to in terms of cosec theta. This was our question, that we have to convert the tan theta to the cosec theta. So what we have learned here is that one trigonometric identity can be easily converted into the another one if we know all these identities. Now see the question. Question is, 3 sine 30 degree minus 4 sine cube 30 degree, and it is sine square, but we don't know. Okay, 30 degree we know, sine 30 is 1 by 2. This I know, I can just directly put the value. But what about cos 50 and sine 50? We haven't learned these ratios, right? So what we can do here is, see, if I take the 2 common from the base, it will be 3 sine 30 degree minus 4 sine cube 30 degree divided by this and this. If I take 2 common, what will left? After taking 2 common from here, sine square 50, no? In the second one, it will be cos square 50 degree. Is it okay? So sine square theta plus cos square theta, because the angle is same. So what was the identity? Sine square theta plus cos square theta is 1. Good. So it will become how much? It will be 3 into sine 30 is 1 by 2. So just put the value, minus 4 into 1 by 2 to the whole cube divided by 2 into 1, because sine square theta plus cos square theta, it has an identity that is equals to 1. So we need not learn sine 50 or cos 50. We know the identity. We can just directly put it. Clear? So it will be 3 by 2 minus 4 by 1 by 2 cube is 1 by 8, right? So again it will be 1 by 2, and in the base we have the 2. Okay. This will come to the base. So it will be 3 minus 1 is 2. 2 by 2 by 2. So it will be 1. So your answer will be 1 by 2. Hope the question is clear. If you know the identity, you can just directly apply it. No need of writing the value of the trigonometric ratios if you can apply the identity. Okay. So this thing was clear to me. We can directly write the value for sine 30. So numerator was easy, but in the denominator, after taking 2, it will form an identity, sine square theta plus cos square theta, and that is 1. We just put the value and answer is 1 by 2. Now come to the next one. 1 minus sine square theta into secant square theta, and that is equals to 1. See, what is the issue here? We don't know any relationship directly that is between sine and sec. So how to make a relationship between sine and sec? We can convert this to cos first, and cos and sec, I know they have the relationship that is the reciprocal identity. So our task is to convert this sine to cos first. Let's see, let's take the left hand side now. So in LHS we will have 1 minus sine square theta into sec square theta, right? Using this sec square theta, this is clear in my mind that I should change this sine from here, right? So which identity I should take? What is the relation between sine and cos? Good, that is the unit identity. And what is that? Sine square theta plus cos square theta equals to 1. But I don't want the value of sine square theta plus cos square theta. I want 1 minus sine square theta. So what I can do here is I can shift this sine to another side. So cos square theta will become equal to 1 minus sine square theta. What we have learned from here is that in place of 1 minus sine square theta, I can put the value as cos square theta. So let's put it. So it will become cos square theta into sec square theta. We know a direct relationship between cos and sec. What's that? Reciprocal identity means sec square theta is 1 by cos square theta. Okay. We can cancel out this cos square and cos square, and we will get 1, which is equals to our RHS, and that's what we need to prove. Hope this is clear. What we have to do in these type of questions now, whenever we have to prove any identity, we should try to convert from one trigonometric ratio to another. That's the only point. Now see the next question. Here we have the relation between the cos square theta and cot square theta. Again the same thing. We don't have any relation between the cos and cot. But if I see 1 plus cot square theta, this seems to be an identity, right? What is 1 plus cot square theta? It is equals to cosec square theta. Let's make use of it. Let's see what will happen. So here in the LHS I can write cos square theta will be as it is, and in place of 1 plus cot square theta I can put cosec square theta, right? Now see, what is 1 by cosec square theta? That is sine square theta. So cos square theta plus sine square theta. It is very famous identity. Cos square theta plus sine square theta is 1, right? So this is equals to your RHS, hence proved. And the question easy. If you know the identity, if you know that in the questions you just have to convert from one trigonometric ratio to another, you can solve the question. Clear? Come to the next one. Here we have to establish a relation between cot and sine. Cot and sine. Again the same thing. But see, cot and cosec, I know the relation, right? Tan and sine, I know the relation. Sine and cos, I know the relation. But there is no direct relation between cot and sine, right? But I know one thing. 1 by sine square theta is how much? Sine square theta is the reciprocal of cosec, because 1 by sine theta is cosec theta, right? Reciprocal identity. So 1 by sine square theta will be equal to cosec square theta, na? Alright, let's put the value. So 1 by sine square theta can be written as cosec square theta. Now cot and cosec, they have something in common, and that is cosec square theta is 1 minus 1 plus cot square theta. Okay. So in place of cosec square theta, I can put the value 1 plus cot square theta. Right. So it will become cot square theta minus 1 plus cot square theta. Okay. When we move this minus sign inside, it will be minus into 1, minus 1, and minus into plus will be minus. So minus cot square theta. Now we have cot square theta and minus cot square theta. They will cancel out each other. So the final answer will be minus 1, and that is your RHS as well. Okay. Hence we have proved this identity. Coming to the next one. Proved it 1 plus tan square theta sine and sine. Okay, there is a relation between tan, sine and sine. But when we check this question now, it is see 1 plus sine theta, 1 minus sine theta. Oh, it is something, right? In our lower grades, we have learnt one identity. What is that? That a plus b into a minus b, and this is equals to a square minus b square. You know this identity? Let's make use of it. So 1 plus tan square theta. Here we will have 1, because a is 1 here and b is sine theta, right? A plus b, a minus b. So a minus b square. A square is 1 square minus sine square theta. Any doubt in this? Okay. So this will be 1 minus 1 plus tan square theta is, this is identity, Good, that is secant square theta. And if I ask you 1 minus sine square theta, see again. So sine square theta plus cos square theta is 1. Why I'm using this identity? Because after looking at sec, na, cos comes to my mind. That cos is the reciprocal, right? So cos will try to cancel it out. So I'm trying to convert this sine to cos. Why? Because sec is there and sec is the opposite of cos, right? There is a direct relation between the sec and cos. So 1 minus sine square theta is, if I shift this sine to another side, it will become 1 minus sine square theta. It means that in place of 1 minus sine square theta, I can write cos square theta. So let's put the value cos square theta. Sec square theta is just the opposite of cos, so I can write it as 1 by cos square theta into cos square theta. Both will cancel out and we will get 1, which is your RHS. If you still haven't learned the identities, the relation in that we have discussed, the first thing you should learn is the reciprocal identity. You should know what is sine, the opposite is cosec, cos, the opposite is sec, tan, the opposite is cot. These are the three reciprocal identity. Alright, then we know that tan theta can be written as sine theta by cos theta. Okay, and the third thing that you should learn is sine square theta plus cos square theta is equals to 1. 1 plus tan square theta is sec square theta, and 1 plus cot square theta is cosec square theta. All these identity you should learn, then only you can solve the questions. Otherwise it will be difficult for you, because in each and every questions we have to just convert the trigonometric ratio and you will get the answer. Coming to the next question now. See the question. The question is between sine and sec. Means again sine should be converted into cos, right? But they are in the denominator. I don't have any identity that directly converts them. If there were a square of sine, then it was easy to convert to cos. But here, let's see what we can do is, we can just take the LCM. Na? What will be the LCM of 1 plus sine theta and 1 minus sine theta? Good, it will be 1 plus sine theta into 1 minus sine theta. Okay, if 1 plus sine theta is being converted into this, or in 1 plus sine theta I have multiplied 1 minus sine theta. So numerator as well we will have the same. It will be 1 minus sine theta. Clear? For the second one it is 1 minus sine theta. So in the numerator it will be 1 plus sine theta. Alright. Now see the numerator part. 1 and 1 will make 2, but this is negative sine theta. It is positive sine theta. They will cancel out each other. So they will form 2 by, again the same identity, a plus b. A plus b and a minus b. 1 plus sine theta and 1 minus sine theta. It is equals to 1 square minus sine square theta. Let's solve this. It will be 2 by 1 minus sine square theta is how much? Again the same one. Sine square theta plus cos square theta is 1. So 1 minus sine square theta is, good, you should learn this, 1 minus sine square theta directly, cos square theta, right? So it is cos square theta. We know 1 by cos square theta is secant square theta. So I can directly write it as secant square theta. And that is your RHS. Hence proved. Clear? Come to the next question now. We have cosec square theta and sec square theta here. Cosec and sec, and in the multiplication we have. But I don't know any relation that is with them, cosec and sec. But I know one thing. The opposite of cosec is sine. The opposite of sec is cos. and we have the relation in them as well, right? So let's give it a try. So instead of directly using, I can just convert them into sine and cos, right? And this is my LHS, right? Cosec square theta is how much? Very good, 1 by sine square theta. Similarly, sec square theta is how much? 1 by cos square theta. If I take the LCM, it will be sine square theta, cos square theta. So sine square theta, I will have cos square theta in numerator. And for cos square theta, I will have sine square theta in numerator. Sine square theta plus cos square theta is 1. So it is 1 by sine square theta, cos square theta. Clear? What is 1 by sine square theta? It is good cosecant square theta. And the opposite of cos square theta is sec square theta. And that is equals to my RHS, cosec square theta, sec square theta. And that is your RHS. Clear? Don't get afraid of the trigonometric identities. If we don't know the identity, if we don't know the method, then it will feel like it's really a burden thing. But believe me, if you are with us, if you are solving each and every question with us, then it will be very easy for you, right? Just learn all the identities. They are really easy, right? 4 to 5 identities you have to learn. You just have to make use of it, and the trigonometry will be very easy for you. It will be very handy. Okay, see the question now. It is sine and you have to convert into sec and tan, right? Sec and tan. And everything is in the root as well. Let's take the LHS again. Under root 1 minus sine theta divided by 1 plus sine theta. I don't know what we should do here. Our first priority is we should remove this under root because it is creating a problem now. Alright. In the lower grades, you must have known that if something is inside the root, then how to remove it? Good, we rationalize it. How to rationalize it? Whatever is in the denominator, we just change the sign in between and we multiply numerator and denominator by that. What does I mean? 1 plus sine theta is written, so I multiply the numerator with 1 minus sine theta. Just change the sign what is in between. That is rationalization. Okay? And in denominator as well, multiply the same thing. Clear? If 1 minus sine theta was there in the denominator, you have to multiply by 1 plus sine theta. If 1 plus sine theta is in the denominator, you have to multiply by 1 minus sine theta. You just have to change the sign which is in between. See, it is 1 minus sine theta into 1 minus sine theta. So it will become how much? 1 minus sine theta the whole square divided by a plus b and a minus b. Again, a square minus b square. Any doubt in this? I just rationalize the denominator. Okay. Multiplied with this. Same thing being multiplied. I can write it as whole square. And this is this. Okay. If whole square is there and root is also there, means I can directly write it as 1 minus sine theta. Divided by, it is 1 minus sine square theta. And what is 1 minus sine square theta? Good, cos square theta. So root of cos square theta, it will be root of cos square theta, right? So finally it will be 1 minus sine theta by cos theta. It can be written as, because this cos is in the denominator, it is with the first term as well as with the second term. It will become 1 by cos theta minus sine theta by cos theta. Okay. So 1 minus cos theta and sine theta by cos theta, I can write it as 1 by cos theta is secant theta, and sin theta by cos theta is quotient identity tan theta. Good. So this is equals to your RHS as well. Hence proved. Easy na? So always remember, if something is written in the under root na, how our first priority should be to remove that root. How to remove the root? If you can make any identity, that's better. If not, then rationalize it. Rationalization means if two numbers are written and they are joined by plus or minus sign, just change the sign. Multiply the numerator by that and denominator by that, and you will get the answer. Clear? Coming to the next question now. In the question, it is written 1 minus sine theta by 1 plus sine theta. This is equals to sec theta minus tan theta the whole square. Means now we have to convert sine to sec and tan. Okay, sec and tan, they have a relation. But with sine, how to make it? Again a confusion. Alright. What we did in the last question was, did we? Very good. We rationalize the denominator. Whenever we see these type of questions, we have to rationalize the denominator. Then only something will be visible. Because if it was sine square theta, I know it will be a relation with sine and cos, right? If cos is there, direct relation with sec. But if simple sine is written, it means there is nothing, right? So what we have to do? We have to rationalize the denominator. How to rationalize it? So if we take the LHS, so LHS is 1 minus sine theta divided by 1 plus sine theta. I will try to convert it into sine square theta form so that I can make the relation or I can make the identity out of it, right? So rationalization means whatever is written in the denominator na, if positive sign is there, it will become negative. If negative is there, it will become positive. Because why we do so na? Someone asks us in rationalization why we change the midterm sign. Because rationalization is that we want to remove this denominator anyhow, right? We want to make this denominator what? A solvable thing, right? So it will form a formula a plus b, a minus b. So we change the sign in order to use this formula a plus b into a minus b. So here what I will do, I will multiply the numerator with 1 minus sine theta and the denominator also with the same thing. Clear? What will happen to the numerator? It will be 1 minus sine theta into 1 minus sine theta. That is 1 minus sine theta the whole square. Clear? And in the base, it is 1 plus sine theta into 1 minus sine theta. Means a plus b, a minus b. So a minus b the a square minus b square. Clear? Because a plus b into a minus b is a square minus b square. Na? If it is a square minus b square, 1 minus sine square theta, it is good cos square theta. Using this identity, see if you are confused now, sine square theta plus cos square theta is 1. And I know if I shift sine to another side, so it will become cos square theta equals to 1 minus sine square theta. So in place of 1 minus sine square theta, I put it as cos square theta. Clear? And another one will be 1 minus sine theta the whole square. If I see this, it is 1 minus sine theta by cos theta and the whole square. Since it is in denominator, I can shift this cos theta with 1 as well as with, because LCM means what? It is with the first term, also with the second term, right? So I can write it as 1 by cos theta minus sine theta by cos theta. What is 1 by cos theta? It is sec theta And what is sin theta by cos theta? It is tan theta and the whole square. And that is equals to the RHS. Clear? Hope the question is clear now. The next question is, you have to prove this identity, sin theta by 1 minus cos theta, and it should be equal to cosec theta plus cot theta. Means again in the denominator I have 1 minus cos theta. I know if I wish to change it, there should be cos square theta or something like that, right? But how to convert it? Good. Again rationalization, or multiply the numerator and denominator with, by changing the sign, right? So I will multiply the numerator with 1 plus cos theta and denominator also by 1 plus cos theta. So denominator will become how much? A plus b and a minus b. So denominator will be a square minus b square. Okay? And the numerator will remain same, sin theta 1 plus cos theta. Can you tell me what we should do now? Good. So 1 minus cos square theta I can use from here. That sin square theta plus cos square theta is 1. So 1 minus cos square theta is sin square theta, right? So sin theta into 1 plus cos theta by 1 minus cos square theta is sin square theta. So sin square theta. Clear? Sin theta cancel out. So your finally it will be 1 plus cos theta by sin theta. Now again this sin theta is with the first term, also with the second term. So I can write it as 1 by sin theta plus cos theta by sin theta. Both are the identities. What is the reciprocal of sin theta? 1 by sin theta is cosec theta. And what about this? Cos theta by sin theta, it is quotient identity. Good. Cot theta. And that's what we need to prove. Clear? Now coming to the next identity. We have to prove that cosec theta minus cot theta the whole square. I know if the right hand side were given to me, what I will be doing? I will rationalize it. I will multiply the numerator with minus cos theta and the denominator also with 1 minus cos theta. But here, if we wish to prove from LHS to RHS, then we need to expand what is written, right? So let's see. Cosec theta minus cot theta the whole square. Cosec theta minus cot theta the whole square. What is cosec theta? Cosec theta is 1 by sin theta. And using the quotient identity, what is cot theta? Cot theta is, in terms of sin and cos, cos theta by sin theta. Any doubt to anyone? Okay. So I can write it as 1 minus cos theta the whole square divided by sin square theta. Alright. Just what we did in the last question or just the reverse of it. In place of sin square theta, what we can put? I know sin square theta plus cos square theta is 1. So in place of sin square theta, we can put 1 minus cos square theta. Okay. So it will become 1 minus cos theta the whole square divided by 1 minus cos square theta. So this is, if we see the base, it is a square minus b square type of thing. And why I want this? Because in the numerator it is a square, but in the answer I just want it one time. So anyhow I should cancel this, right? So a square minus b square means a plus b minus b. So 1 minus cos theta the whole square divided by 1 minus cos theta and 1 plus cos theta. This will cancel out. So whatever is left, that is your answer. 1 minus cos theta by 1 plus cos theta. Right? Means you have to just check what is in the RHS. It will be easy. So the same thing applies with the maths also. Maths is really very interesting subject. The point is you should know the concept clearly. Why we are taking that step, the reason behind that should be clear to you. It's really easy. See all the questions. Most of them are from the previous year questions. Okay. When the students attempted them in the exam, they were like, oh, the paper is tough. But see, isn't it easy? Right? So if you know the correct approach, then it will be easy. So stay with us in the channel, right? Solve each and every question. Whatever I ask you to learn, just learn it. Now coming to the next question. This time it is cot theta minus tan theta, and we are changing it into sine and cos, right? Means cot and tan is given and you have to write it in terms of sine and cos. Okay, let's give it a try. So LHS is cot theta minus tan theta. We know what is cot theta. Cot theta is cos theta by sin theta, and tan theta is sin theta by cos theta. Clear? Now taking the LCM, it will be sin theta cos theta. Sin theta already there, cos is there, so it will become cos square theta. Cos already there, so sin. So sin square theta. Any doubt in this? Okay, but see, in the right hand side, okay, base is same, no doubt, but I don't want sine here, right? So sine, I know how to, what is the relation between sine and cos, right? What's that? That sine square theta plus cos square theta equals 1. Whenever we see sine square or cos square, we can use this identity. Most of the time you will get answer just by using it. Okay, so in place of sine square theta, what I can write is, it is equals to 1 minus cos square theta. So let's put the value. Cos square theta minus, place of sine square theta, 1 minus cos square theta divided by sine theta cos theta. Okay, next, just open it. Cos square theta minus into minus 1, it is plus cos square theta. Let's write it somewhere else. Okay, let's shift it there. So it will be cos square theta minus 1 plus cos square theta divided by sine theta cos theta. Clear? Now see, cos square theta and cos square theta means 2 times cos square theta minus 1 by sine theta cos theta, and that is equals to your RHS. Okay, so here LHS and RHS both are same, means we have proved the identity. Remember, this is very, very important. Sine square theta plus cos square theta equals to 1. Now again, check it out. Every time when I show you the identity, because now you know how to solve this, what you have to do with me, just have to pause the video. Alright, just give it a try. If you can solve it, okay, check my steps, check the final answer. But if you are stuck, just be focused on my answer, right? Clear? Okay, but you have to stop the video, give it a try, use the pen and copy, okay? Don't just sit there and just listen like I'm telling any story or something. No, You have to keep your pen and copy with you. Whatever I am saying, just write it, try to solve the question by yourself, and then check my solution. Clear? Because now we have done a number of questions. All right, let's try to solve this. 10 and sine is given, and we have to convert it in the form of sec. Sec means related to cos, means we should open this 10 first. All right, okay, let's try to open this 10. 10 can be written as sine theta by cos theta plus sine theta, and 10 theta again sine theta by cos theta minus sine theta. Any doubt? The numerator will become, if I take the cos, it will be sine theta plus sine theta cos theta. Similarly, denominator, it will become sine theta minus sine theta cos theta by cos theta. This cos theta will cancel it out. So what will happen? It will be equal to sine theta plus sine theta cos theta divided by sine theta minus sine theta cos theta. All right. If I take out this sine theta cos theta common, okay, if I just take out sine theta common, I will be left with 1 plus cos theta. Again sine theta common from this. So this sine theta will get removed, and it will be 1 minus cos theta. In cos I have the answer, but I want the answer in sec. What I will be doing? I will convert this cos to sec. How to convert cos to sec? Cos theta can be written as 1 by sec theta. 1 by sec theta. Now taking the LCM, what I will get? Sec theta plus 1 by sec theta minus 1, because sec and sec will cancel out. Clear? And that is equals to your RHS. See the next question now. In this question, cos and tan is given, sine and cot is given, and answer, every time you have to check the answer, means what we have to prove. And the proof is everything should be in terms of sine and cos only, right? Okay, we know how to open this tan and cot, right? So it will be cos A by 1 minus sine A by cos A. Is it okay? And sine A by 1 minus cos A by sine A. Hope it is clear. Alright. If I solve the denominator part, what will be there? The denominator will be cos A and this cos A minus sine A. I am taking the LCM, right? So cos A by, it will become cos A minus sine A by cos A. Alright. Similarly, sine A by sine A minus cos A by sine A. Now denominator of denominator, right? Denominator of denominator becomes the numerator. So it will become how much? Cos square A by cos A minus sine A. Right? And here it will become sine square A by sine A minus cos A. Just see one thing. Isn't the base same, just a change of sign? There is cos B is positive here, here cos is negative. Here sine is negative and here sine is positive. So it means if I wish to write it in one term like cos A minus sine A, I have to put a minus sign over there, right? Cos square A minus sine square A. Is this clear? Again, this is the identity a square minus b square. So I can write this as cos A plus sin A into cos A minus sin A divided by cos A minus sin A. This will cancel out. What we have finally? Cos A plus sin A. And that is our RHS as well. Hope it is clear. One more thing that we should remember in our mind is, see, I know that sine square theta plus cos square theta, this is equals to 1. I know this thing. So whenever I see, if I shift cos to that side, so sine square theta, I can directly write 1 minus cos square theta, right? So whenever I see 1 minus cos square theta, it is equals to sine square theta. Same thing for the cos square as well. If I shift sine to this side, it will become cos square theta equals to 1 minus sine square theta, right? So remember this thing directly, that 1 minus sine square theta is written, then it is equals to cos square theta, and if 1 minus cos square theta is written, it is equals to sine square theta. Come to the question now. See, what is written? It is sine theta and 2 sine cube theta. In the base we have something about cos, right? What we can do in the numerator, and we have to equate it to tan theta. Tan theta is sine theta by cos theta, right? Means I want some sine theta type of thing in the numerator and cos theta type of thing in the denominator. That's it. See, what we can do in this is, in the numerator, can't I take sine theta common? Okay, if I take sine theta common from the numerator, so the first term will become 1, because sine theta I have taken common. In the second one, it will be 2 sine square theta. Is this clear? See, in the base what I will be having, I can take cos theta common, and first term will be 2 cos square theta minus 1. Is this clear? Alright, now what is this? 1 minus 2 sine square theta and 2 cos square theta minus 1. I just learned about this, that if I have 1 minus sine square theta, this can be written as cos square theta. Okay, so 1 minus, it will be sine theta, 1 minus 2 sine square theta. Okay, so 1, I can write 1 as sine square theta plus cos square theta, right? Minus 2 sine square theta. Any doubt? In the base, I can write cos theta and 2 cos square theta minus sine square theta plus cos square theta. Any doubt to anyone in this? I just substituted the value of 1 as sine square theta plus cos square theta. Now what will happen? See, sine theta by sine theta will remain same. It will become sine square theta minus, it will be cos square theta minus sine square theta. Hope this is clear. In the base, cos theta will remain same. Now subtract. 2 times cos square theta is there and minus cos square theta is there. So it will become, good, cos square theta minus sine square theta. See, this part cos square theta minus sine square theta and this part cos square theta minus sine square theta, both are same. We can cancel out them. So it will become sine theta by cos theta, and that is equals to your tan theta, right? So the identity sine square theta plus cos square theta, that is really very important. Why? Because whenever we will see the relation in sine and cos and 1 is written there, so we can use sine square theta plus cos square theta in place of 1. Similarly, if we see the relation between the tan and the sec, so in place of 1, what I can write? Sec square theta minus tan square theta, because 1 plus tan square theta is sec square theta. Okay, come to the next question now. The next question is this one. Okay, if I see the left hand side, cos theta, this, it seems to be familiar, no? Cos theta, sin theta, no? So again we can take common cos, right? If I take cos common in the numerator part of this, first term will become 1, second term will become 2 cos square theta. In the base, sin theta common, and it will be 1 minus 2 sin square theta. Okay, again something is in cos theta and sin theta, right? What we can do? In place of 1 we can write sin square theta plus cos square theta. Here in place of 1 I can write sin square theta plus cos square theta. Here as well I can write sin square theta plus cos square theta. Let's write it. So it will become how much? Cos theta into sin square theta plus cos square theta minus 2 cos square theta. Hope it is clear. In place of 1 I put the value of sin square theta plus cos square theta. That's it. In the base as well I will do the same. Sin theta into sin square theta plus cos square theta minus 2 sin square theta, and plus cot theta is already there. Clear? Now what we can do is, in the next step we can cos theta is already there. So sin square theta, cos square theta minus 2 cos square theta, it will become sin square theta minus cos square theta. See, because 2 cos square theta is in minus, this is in plus, so we will subtract them, right? So minus 2 plus 1 is minus 1. Okay. In the base, what we will have? Sin theta into sin square theta minus 2 sin square theta, it is good, minus sin square theta plus cos square theta, and cot theta is already there. Okay. Now what we can do here is, see, both the things are same. Here just sin is positive, here sin is negative, here cos is negative, cos is positive. Means if I take minus 1 common, both will become same, right? If I keep the numerator same, cos theta sin square theta minus cos square theta, and in the base I take minus common, so what will happen? This minus will become plus, so it will become sin square theta minus cos square theta, and cot theta was already there. Clear? Now this and this will cancel out. Cos by minus sin is minus cot theta, and cot theta was already there. So this will become equals to 0, which is our RHS. Hence proved. So what was the trick here? Again the same trick, that in place of 1 we have to put sin square theta plus cos square theta. And in this step, when the sign were different, what we have to do? We have to take minus 1 common in order to cancel them out. Come to the next one. It is relation between cosec sine, just the reverse, right? They are the reciprocal. Second cos, again reciprocal, tan and cot, right? So we will try to convert everything into the simple form first, because they are the reciprocal, right? So cosec can be written as, good, 1 by sine theta minus sine theta. Okay. Second be written as 1 by cos theta minus cos theta. Okay, tan we can remain tan, and cot will be 1 by tan theta. Hope it is clear. It is not the case that you have to convert cosec to sine only. No, you can convert sine to cosec also, right? It's completely up to you. You will get the correct answer. Alright. If I take the LCM for the first one, For this one, for the first term, if I take the LCM will be sine theta. Okay. So it will become, because it was 1, right? If nothing is written means 1 is there. So 1 and sine theta, LCM is sine theta. Numerator will be 1 minus sine square theta. Why sine square theta? Because 1 into sine theta will make the denominator as sine theta. Na? So if I am multiplying the base with sine theta, numerator should also be multiplied. So it will become sine square theta. For the second one, it will be cos theta. Cos theta, it will remain 1. But 1 into cos theta makes cos theta. So numerator also multiplied. Cos square theta. Clear? If I check here, it will be 10 square theta plus 1 by 10 theta. Hope this is okay. Alright. Now coming to the next one. What we will be getting? 1 minus sine square theta is? Good. This is cos square theta. We just learned it. Sine square theta plus cos square theta is equals to 1, right? We learned that, no? Sine square theta plus cos square theta is 1. So 1 minus sine square theta is cos square theta and 1 minus cos square theta is sine square theta. Let's make use of it then. This will be sine theta. So 1 minus cos square theta is sine square theta by cos theta. We know this identity as well. 1 plus 10 square theta. What is 1 plus 10 square theta? Good. Sec square theta. It is sec square theta by 10 theta. Any doubt? Now we can cancel them out. Okay. Cos theta cancel out. Sin theta cancel out. Now sec square and 10. We can further write them like, what is sec square? Good. It is 1 by cos square theta. And what is 10 theta? 10 theta is sin theta by cos theta. Now cancel them out. Sin theta, cos theta, and cos theta. Means final answer will be 1, which is your RHS. Okay? Means in this question, again the same rule, sin square theta plus cos square theta, if we know, we will just put the values. Whatever is written, we just have to open it. Because we know here the reciprocals are written, right? So we just converted them into their reciprocal trigonometric entity and just solve the question. Let's solve this question now. What we have in this question is, we have the term cot theta and along with that cosec theta. Then we have tan theta and sec theta. Now what we can do here? Because if it were cot square or cosec square or tan square or sec square, we know the identity, right? But here what to do? We can't do anything. So what we can do here is, we can just convert them to sine and cos. If we can't find anything, just convert them to sine and cos. You will get something. Okay? So let's convert it. 1 will remain 1. Cot theta can be written as cos theta by sine theta. Cosec theta can be written as 1 by sine theta. For the second term, tan theta can be written as sine theta by cos theta. And sec theta can be written as 1 by cos theta. Clear? Now see here. This 1 can be written as 1 by 1, right? This also 1 by 1. Now if I see the denominator, here the LCM of 1 and sine theta is sine theta. So I can write sine theta here. 1 is being converted to sine theta, means the numerator will also become sine theta. Now sine theta to sine theta, so whatever is there, no change. Sine theta to sine theta not changing. If denominator not changing means numerator will also be the same. Clear? Now see, 1 and cos theta, what will be the LCM? Cos theta. Now 1 I am converting to cos theta, means in the denominator I am multiplying cos theta. So in the numerator also I will multiply by cos theta. In the second term, cos theta is cos theta only, right? I'm not changing anything, so numerator will also not change. Denominator number 3, I'm not changing, cos theta remains cos theta, so numerator is also same. Is this clear? Now, what choice we have now? We can just multiply them, right? So this sine theta will be multiplied with this cos theta first. So it will become sine theta cos theta. Now this sine theta into sine cos theta, we did sine theta into sine theta, sine square theta. Sine theta into 1, sine theta. Take the another term now. Now cos theta will multiply with all these things, right? So cos theta into cos theta, cos square theta. Cos theta into sine theta, cos theta sine theta. And cos into 1, so it will be cos theta. Now minus 1 into cos theta is minus cos theta. Minus 1 into sine theta is minus sine theta. Minus 1 into plus 1 is minus 1. And in division, sine theta into cos theta is sine theta cos theta. Now see what we are getting here. We are getting minus sine theta and plus sine theta. They will cancel out each other. Okay. Then we have cos theta and cos theta. They will cancel out each other. Okay. Now what we have in numerator? Sine theta cos theta means 2 sine theta cos theta. Okay. We can write 2 sine theta cos theta. Clear? What other thing we have? Sine square theta plus cos square theta. What is sine square theta plus cos square theta? That is 1. We know the identity. And we have minus 1. Minus 1 by sine theta cos theta. Any doubt? LHS has become to this, right? Now, plus 1 minus 1 will cancel out. That will make 0. What we have next? It will become equal to 2 times sine theta cos theta divided by sine theta cos theta, cos, sine, and at last we have 2, and this is equals to our RHS. See, this is what we have to prove, right? We have to prove it equal to 2. Now, and if we can't see any identity directly, what we can do is the simple method is just convert the question into sine theta and cos theta. Okay, just solve it normally and you will get something. Clear? Next question. Now see what we have. We have sine cosec. Cos and sec means their opposites are with them. But at last we want tan and cot. Yes, na? I have again two choices. Either I can convert everything to sine or cos format, right? Or I can see one thing. If I'm getting tan square theta and here is a square and I have cos sec and I have sec. So conversion of sec to tan is very easy when square is given. In the last question, na, why I didn't convert it? Because the square was not there, right? Square was not there. But here square is given, means it's easy if sec square is given to convert to tan square. Similarly, cosec square will be there and conversion to cot square. Let's give it a try. Means this time we are not going to convert to sine and cos. If you are converting, then also you can solve the question. I'm not saying it can't be solved then. Okay, it will be, but it's easier if you can see the direct identity. Okay, let's give it a try. So this one, a plus b the whole square. What is a plus b the whole square? Sine theta plus cosec theta. A plus b the whole square is a square plus b square plus 2ab. Right? Let's make use of it. So sine theta, first one will become a plus b the whole square will become sine square theta plus cosec square theta plus 2 sine theta into cosec theta. Right? Similarly, the second term will become cos square theta plus sec square theta plus 2 cos theta sec theta. I hope the LHS is clear. Right? Okay, this thing sine into cosec means both are reciprocal of themselves. So they will cancel out each other because cosec is 1 by sine, right? Similarly, cos into sec, this will also make 1. Okay, so what I can, because see, I know now that sine theta equals to 1 by cosec theta, right? So if I multiply it here to sine into cosec, it is equals to 1 now. So in place of this, I have put 1, right? Now what I'm getting? I'm getting sine square theta plus cosec square theta plus 2 plus cos square theta plus sec square theta plus 2. Any doubt? Okay. So now sine square theta plus cos square theta, this is directly 1. 2 and 2 will make 4. Now how to write cosec in terms of cot? Good. It is 1 plus cot square theta. And how to write sec in terms of 10? It is 1 plus 10 square theta. Now see what I am getting. 4, 1, 5, 6 and 7. So 7 plus 10 square theta plus cot square theta. Clear? Easy na? If you wish to solve it by converting into the another format, na, that's also you can do, right? Not an issue. See this question. In the question, we are given the relation between sine and sec, cos and cosec. Means this time it is not between sine and cosec and sec and cos, right? So again we have the two choices. Either we can open the whole square or we can convert everything to sine and cos. Opening the whole square will be a bit difficult because it is a plus b the whole square. So I will get square of sine, square of sec, and then the term 2 sine theta sec theta. And I don't know how to solve 2 sine theta sec theta because they are not opposite of each other also, right? So it's better we convert them into sine and cos, right? Let's convert. So LHS will become sine theta will remain same. Sec theta can be written as 1 by cos theta the whole square. Second term will be cos theta plus 1 by sine theta the whole square, right? Now open the whole square. So the whole square will be opened by a plus b the whole square. So a square sine square theta, then b square 1 by cos square theta, then 2 times ab sine theta by cos theta. Clear? Now for the second one, it will be a square means cos square theta plus 1 by sine square theta plus 2 times cos theta by sine theta. Clear? Let's see what we are getting. Just open them. It will be sine square theta plus 1 by cos square theta plus 2 sine theta by cos theta. Here it will be cos square theta and 1 by sine square theta and 2 cos theta by sine theta. Check out these two terms. Sine square theta plus cos square theta. It will make 1 na? This term and this term, right? They will make 1 plus, let's keep them together, 1 by cos square theta plus 1 by sine square theta. Then I have 2 times of sine theta by cos theta and cos theta by sine theta. Clear? Now how to convert it now? 1 will remain same. We can take the LCM of these two terms, right? So we have 1 plus 1 by cos square theta plus 1 by sine square theta plus 2 times of sine theta by cos theta and cos theta by sine theta. Sine theta by cos theta and cos theta by sine theta. right? Let's try to convert them into the form now. Just take their LCM. It will be sine square theta cos square theta. Okay, it will become how much? Sine square theta plus cos square theta. Clear? Similarly, if I take the LCM here as well, so it will be cos theta sine theta. It will become sine square theta plus cos square theta. Okay, 1 will remain same. Sine square theta cos square theta will make 1. So 1 by sine square theta cos square theta. Okay, this will be 2 into 1. So 2 by sine theta cos theta. Now see, what we have to convert? I have to convert it into a whole square format. 1 plus, very good, 1 by cos and 1 by sine the whole square. So if I try to see this, what is it written? Can't I read it? This is first term means 1 square. A square plus B square and plus 2AB. Yes or no? Isn't it the formula now? A square plus B square plus 2 into A into B. So this is equals to A plus B the whole square, means 1 plus 1 by sine theta cos theta the whole square. Okay, sine theta can be written as cosec theta, 1 by sine theta, and 1 by cos theta is sec theta, and that is your RHS. See, clear? So it's up to you how you wanna solve it, but the problem initially was we don't know what to do when sine and sec will come, right? That's why I converted it into the sine and cos format, and I just solved the question. Hope it is clear. Now again one more question, but this time you need not prove anything. You have to find the value of x. You have to find the value of x, and it is given that sine and cosec the whole square, means they are just the opposite. Here I can open them, right? Because they will cancel, 2ab will cancel out, right? Here also cos and sec, but at last I want this tan and cot, right? Okay, let's see what will happen. So it will become sine square a plus b the whole square, na? So a square plus b square. And why I am opening it? Because conversion of cosec to cot and conversion of sec to tan is easy. That's why I am opening it. Otherwise, I would have converted it into sine and cos format, right? This is how you have to decide which type you have to follow, okay? So this will become 2 times of sine into cosec, that is 1, so 2 only, right? Another one will become cos square a plus sec square a plus 2 times cos sec a. Cos sec a is 1, right? Clear? Now sine square a plus cos square a will make 1. Okay, and I will get 2 and 2 is 4 plus cos square a plus sec square a. So cosec square a plus sec square a. Now I want the answer in tan and cot. So it will be 5 plus cosec can be written as, cosec square a can be written as, good, 1 plus cot square a. And sec square a can be written as 1 plus tan square a. So 5, 1, 6 and 7. So 7 plus tan square a plus cot square a. This will be my answer. But now here we have to find the value of x. Now see, tan square a is already there, cot square a is already there. So x will be how much? 7. On comparison, we are getting x as 7. Clear? This is our answer. In these type of questions, we just have to decide which thing we have to follow. We have to open the whole square, okay, or we can convert it into sine and cos. And with this, we have completed our part 3 as well. Hope you liked the video. If so, Just hit the like button, share with your friends, and subscribe for more such videos. Thank you.
Like and subscribe.